VCB Electronics has an extensive screening infrastructure, equipment, instruments and processes meeting MIL 883 standards to identify robust circuits that can withstand harsh operating conditions needed for both payload grade as well as ground electronics grade requirements. VCB has capabilities to build the test jigs, test automation, monitoring and reporting templates that can be customized as per the product or application requirements. The screening process starts with visual inspection of each hybrid microcircuit package, where markings, physical condition of each package, imperfections if any, get recorded, followed by complete electrical testing. All electric parameters get recorded and logged through automation or manual process. Then, the packages go through stabilization bake of 72 hours at 125 degrees Celsius to determine the effect of storage at elevated temperatures without applying electrical stress. This is followed by passive or non-powered temperature cycling between, say, -55 degree and +125 degrees Celsius for specified number of cycles to determine the ability of the package to withstand rapid change in temperature within an environment. The test is designed to accelerate the effects of thermal mismatch amongst the die or assembly components. Thermal cycling is followed by constant acceleration at 1000 G or 5000 G for 1 minute to ensure the substrate to package attachment strength and particle impact noise detection test, which helps to detect loose particles inside an electronics device cavity. Then the packages are subjected to electrical testing, where all functional and electrical parameters are recorded before putting them into a burn-in chamber for 168 to 320 hours at 125 degrees centigrade in a powered condition. This electrical stress test typically employs voltage and temperature to accelerate the appearance of latent defects in a device. The objective of burn-in is to eliminate all potential failure likely to occur at the early phase of the product lifetime. The packages are moved from the temperature chamber and subjected to electrical and functional testing, followed by recording and calculating drift or change in the pre and post values. This is followed by active temperature cycling or ATC test and post-ATC electrical testing. Again, any drift in electrical parameters are recorded. Now, the packages go through fine and gross leak tests to determine the effectiveness of package seals in microelectronic packages. Damaged or defective seals and feed-throughs allow ambient air or water vapor to enter the internal cavity of the device, resulting in internal corrosion and leading to device failure. Finally, an electric test, pre-delivery inspection, and a lot screening report is prepared and shared with the customer. For space applications, customer mandates critical to quality qualification. As part of CTQ life test of 2000 hours, powered microcircuits are kept in a thermal chamber at 125 degrees Celsius and monitored over 2000 hours. Objective of this test is to establish the functional life in a real working environment. Next, thermal vacuum testing is done for a wide variety of spaceflight components, subassemblies, and mission-critical equipments. It allows for the simulation of space and upper atmosphere conditions, including temperature and altitude. The aim of the endurance test of 2000 hours is to determine how the system behaves for a long period of sustained use. The major issues like memory leaks, performance degradation, base station connection issues, etc. get noted. Sign on random tests may prove useful to simulate a specific environment with random and tonal components, such as an aircraft package shelf experiencing both random air loads and engine harmonics. Random on random tests superimpose narrow band random noise on broadband random noise. Sign on random tests may prove useful to simulate a specific environment with random and tonal components, such as an aircraft package shelf experiencing both random air loads and engine harmonics. Random on random tests superimpose narrow band random noise on broadband random noise. The purpose of mechanical shock testing is to evaluate the reliability of devices subjected to severe shocks due to abrupt changes in motion produced by rough handling, transportation, or field operation. The objective of thermal cycling test is to determine the ability of parts and solder interconnects to resist extremely high and low temperatures as well as their ability to endure cyclical exposures to extreme temperatures. Final electrical testing as well as pre-delivery inspections get done, and CTQ test reports are delivered to customer along with the tested packages.